Words cannot describe our first speaker. So a new word was created that he is worthy of. Awesomeness. Please welcome Trace Holmes.
It's been said that there are 10 types of people in the world. Those that can understand binary and those that can't.
Oh.
Who here has ever used a computer? A fair number of you. How many of you have ever wondered how the hell that thing works? Anyone? Okay. Fair number. Well, computers don't understand words. They operate on ones and zeros. You may have heard this before. Basically what this means is that they operate on the presence of an electrical signal or the absence of an electrical signal. This is known as digital electronics. This being the presence of electrical signal, this being the absence. This would be over time. As opposed to analog, which can be any number of values between 2 points, such as your radio is analog. What the hell does it mean? What are ones and zeros? This is what binary looks like. That's called a byte. Everyone's heard of a byte?
Yes.
It's made up of 8 bits. Each one of these placeholders is a bit. You've heard of megabytes, gigabytes, stuff like that. Let's look at how we can understand what this actually means. Can someone please tell me what number that is? Shout it out.
283.
How did you know that?
3 digits, and we learned in elementary school that's 100.
That's the perfect answer. We use commonly what's known as base 10 numeric system, meaning that each digit represents a higher order of 10 to a certain power. So the first place, the singles digit, is 10 to the 0th power. Who knows what 10 to the 0th power is?
0.
1. 1. Who said that?
FSU.
Good thing you know that. 10 to the first power is 10. 10 to the second power is 2. Now, to turn these 3 digits into a number that we understand, we multiply them by the value for that place. So this would be 2 times 10 to the second power, which is
200.
Thank you. Plus 8 times 10 to the first, plus 3 times 10 to the 0, which is 200, plus 80. All right. Plus 3. 283. So if you didn't know how our number system works, now you know. And this goes up 10 to the 3rd, 4th, 5th, ever increasing higher. That is base 10 numeric system. Binary operates on base 2 numeric system. The difference being, instead of 10 to increasing powers, it's 2 to increasing powers. So let's look at a binary number. We'll use this one. So this is the first place. We will use 2 to the 0th power for that. And each one increases after that. So 2 to the first power, 2 to the second power, 2 to the third power. What's 2 to the third power?
8.
You said that? Okay, excellent. I just wanted to see who's answering me. So we start off with 1 times 2 to the third power. 0 times 2 to the third power, or 2 to the second power. 1 times 2 to the first. 0 times 2 to the 0th power. And as Jeremy said, that is 8. Plus what's 2 to the second power? 4 times 0?
0.
2 to the first power?
2.
2 plus 0. This number is 10. Wow, that was easy. Did you know that before I did this? Jim? Did you know that before? You did? So essentially, this is how your computer stores information. On your hard drive, in your RAM, it's all 1s and 0s. And you may be thinking, Trace, how the hell do I get Facebook and funny YouTube videos of cats from this? Well, essentially, they are very, very, very long sequences of 1s and 0s that make up, let's call it a code that transcribes to certain characters, the letter A. And then those are built higher into more meaningful programs. So at the very basic level, you have your computer. We'll call it the machine, which is your CPU and RAM, which holds 1s and 0s. Higher than that, you have what's called machine language, which can talk to your machine. And this could be drivers. Most of them are built into your equipment. Then you have your operating system. And then you have your programs, like your Facebook, and your Mahjong, and your Words with Friends. And the way it works is that they each talk to each other in a hierarchical fashion. So, you may be kind of blurry on this subject, but the focus of my speech was binary, not on this. Be looking forward to the next installment of my series, How to Thoroughly Bore Your Audience. Computer, engineering, and mathematics topics, which will surely cover topics like these. Thank you.